Hello, everyone, and thank you for joining this session about how OpenNebula gives power to IG1 Cloud. So let me start with some history. So why OpenNebula and problems to be solved? So some kind of context. In 2018, so 4 years ago, Iguane Solutions, my company, decided to create a team to develop its own IG1 Cloud. It's an infrastructure as a service solution, managed infrastructure as a service. And we decided to develop something new about for our customers. And we had major problems to be solved compared to the current solution we used to based on VMware. We want to accelerate deployment, so industrialize, improve the quality of our service and the reliability by introducing automation process and standards. And second problem to be solved is to visualize. We want to get reporting for the entire virtual machine fleet for us and also for our customer in a dedicated portal. And also, obviously, security. We want to anticipate any issues because it's a managed infrastructure as a service solution. So we want to detect issues and anomalies through a trusted third party. So we want to use an external solution to have something very reliable. So let me start with the first problem, industrializing. So how we decided to industrialize? I missed the more important solution. We want the solution we decided to use is OpenNebula, based on the major ecosystem for storage. We decided to use Storepool. So industrialization. Why Terraform? We decided to use Terraform. Terraform is an infrastructure as code tool, and it helps every DevOps team to deploy very fast on any cloud provider. So as we also use public cloud, we wanted to standard our deployment if like we wanted to deploy like we did on AWS, GCP, or any other cloud solution. We wanted our SRE to use the same tool. So as they are using Terraform, we decided to use Terraform too. So then it's also something that we can speed up resource deployment. So Terraform provide SDK and tools to create modules. Modules is a kind of template of resources to deploy very fast something, all the resources composing an infrastructure. And it's very easy to use. And thanks to that, we can deploy lots of customers in a few clicks. Also, as we are not alone in the team, we want to have something that we can use in collaboration mode. So keep the history in Git and also every change of the platform on a reliable database. And Terraform provides such tools. And obviously, security. We want also to manage a disaster recovery mode. I mean, if something happened in our facilities where the customer is deployed, we want to redeploy it very quickly in other facility as a disaster recovery mode. So how we did it? In 2018, there already a provider for OpenNebula already exists in Terraform. It was developed by Runtastic and BlackBerry team, and it was directly using API from OpenNebula based on XML RPC. However, it was not maintained, and that for us it was a major issue because we have production on our cloud and we want to have something very reliable to be used. So we decided to develop a new provider using also the Go bindings, because Terraform is developed in Golang language. So as OpenNebula provides Go bindings, thanks to the Goka, we decided to redevelop the provider using Go bindings. Actually, our first contribution to the open source ecosystem of OpenNebula was not Terraform, it was the Goka. We decided, thanks to OpenNebula team, to develop a new Goka, to improve the Goka, to have something more appropriate to be used as an SDK for any tools using Golang language. So we decided to redevelop the Goka as the MVC template model, M for model, V for view, and C for controller. Thanks to that, we can instantiate a controller of the Goka for any tools, and then we can manage OpenNebula via this SDK easily with any tools developed in Go. So after developing the Goka, then we started by developing the Terraform provider in end of 18 and beginning of majorly during 2019 year, so 3 years ago. And now we are in 2022, and several releases of the Terraform provider has been made. It was officialized as an official provider of OpenNebula in 2020, if I didn't miss anything. And now we are already in the 0.4 release, and we are working on the 0.5 for a few weeks and maybe few days. We improved the quality of the provider, and also we moved the provider to the new Terraform SDK, the version 2 of the SDK. And then in July, we will have the full support of 1.5.12 LTS release, which is end of life very soon, but we want to have something very reliable and representing major resources of OpenNebula. And after the summer break, we want to support the new 6.4 release of OpenNebula, because the 6.4 will replace the 5.12 as the new LTS. So we want to support the new LTS to be ready by the end of year when the 5.12 will be officially end of life. So that's the roadmap for the Terraform provider. And since it exists, lots of contribution has been made by lots of people, and I want to thank them again about their contribution. And also, obviously, you do not hesitate to open new issues and to contribute on it on the GitHub, on the OpenNebula GitHub. Terraform code is already in it. And any official release are based using this GitHub repository. So thank you again for your contribution. And now I will deal with the new a new topic we did thanks to the Goka too. As I said, the Goka is a very useful SDK. So we had two other issues to deal with. It's the visualize issue and the anticipate one. So for the visualization and the anticipation one, we develop our own small web server called OneRest. It provides a REST API to an internal solution for the reporting based, which use this REST API in HTTP to collect useful business information for our customer and also our operation team. It is operation team and customer to follow their resource deployed on their cloud. I mean, the number of virtual machines, the size of storage they use, and some business metrics such as the CPU and the RAM used, how many storage they have, they used, also if the virtual machine is on or off, and so on. Thanks to that, they can follow easily their usage. And also, the major one, we used Pingdom as the third-party solution to have external monitoring on our cloud and also our infrastructure. And we wanted to use Pingdom to test OpenNebula without opening Sunstone directly. So, and also to not only manage Sunstone availability, we wanted to know exactly the cluster status we have. I mean, any host, we wanted to test if the service is ready for our customer, because for some reason, Sunstone can be down and the VM can still be running. So we wanted exactly to be sure that even if Sunstone is down for maintenance, for example, if the customer service is still running or not. Thanks to that, thanks to our API, we are able to know by cluster, I mean by OpenNebula cluster, and also by host, if it's okay or not okay. That's for our, thank you for that. And so as a conclusion of this meeting, as I said, we had 3 major problems: industrialize, visualize, and anticipate. For the industrialized part, we decided to use Terraform to standardize our deployments. And for the other one, we all developed a homemade API. Both tools used the Goka. And OpenNebula helped us a lot to develop this new product created in 2018. Every year, we doubled the capacity of our cluster, and we started with 10 nodes in end of 2018. Actually, it's beginning of 2019. And we are now 4 times more nodes in production. We started with 1 zone, and now we have a federation of 2 zones with lots of customers using it. We have a mutualized solution, so we deploy VM on this solution, and we also have customers who have their own host, private host, using OpenNebula to have a very reliable cloud solution. Our availability score are very good, and our performance are very good, and customers are very satisfied with this solution because we can deploy them very fast. It's reliable and it works very well. So thank you again and have a nice day, and do not hesitate if you have questions. The Q&A session is open, and I want to thank you for listening. If you have questions, do not hesitate to send them by GitHub directly on the our Terraform provider issues, or our LinkedIn page, or mailing, and so on. So thank you again and have a great day.